Scientists did more and more experiments to understand the atom. They changed their view about the atoms over the period of time. So, in this lecture, we will discuss about the different timelines in which scientists imagined and pictured about the atom. So, in a simple word, this lecture is about the timeline in which scientists have their own opinion and imagination about the atom, and on the basis of that they pictured the structure of atom over the different period of time. The first idea about the smallest particle of a matter was given by an ancient Greek philosopher known as Democritus 2500 years ago. Democritus said that if you imagine you have a piece of a bread and you cut that piece of a bread into very small pieces, eventually you will reach to a point where you will never be in position to divide that bread into further small pieces. He called that small piece, which is indivisible, atoms. Atoms is an ancient Greek word which means indivisible or uncuttable. So, according to Democritus, the smallest particle or the smallest piece of a matter is known as atoms, and atoms is indivisible or uncuttable object. So from Democritus we got first time the idea about the word atom. Democritus said that all matters are made up of different types of tiny uncuttable objects known as atoms. So matter is made up of different type of atoms, and they combine in a matter in a different combination, and at the end they form matter. Dear student, according to Democritus, all atoms are present in different shapes and sizes. So in daily life you see different shapes of matters and sizes of different types of matter. So according to Democritus, you see a different shape and sizes of matter. These matter are made up of atoms, and these atoms have different shapes and sizes. Now question here is that how, according to Democritus, an atom combine with other atom and they form a matter. So dear student, according to Democritus, the smallest particle of atom, matter, which is known as an atom, consists of hooks and holes. So the atom with a hook combined with an atom having a hole. So the hook and hole, they interact with each other, and the atom with hook and atom with a hole interact with each other, they combine and they form a different type of matter. So if I conclude the Democritus atomic model, Democritus said matter is made up of a smallest particle, and these particles, according to Greek, they are known as atoms. The word atoms mean uncuttable. So matter is made up of uncuttable, undivisible particle, and these uncuttable, undivisible particles are known as atoms. Atom present in a different shape and sizes. So in general life you see a matter in a different shape or sizes is formed due to a combination of an atom which have a different shape and different sizes. Now question here is that how a matter is formed and how an atom combine with each other. According to Democritus, a matter has a smallest particle known as an atom. Atoms have hook and holes. Some atoms have a hook and some atoms have a holes. So the atom with the hook combine with an atom with a hole, and when the hook and atom with the hook and hole combine, they form a matter. And the matter with a different shape you see depend on the combination of an atom with a hook and hole. Now, the ancient Democritus idea about the atom was somehow right, but at the same time there was another famous philosopher known as Aristotle. He also gave his idea about the matter, that how a matter is formed. Aristotle said that matter is made up of earth element, water, fire, air, and ether. So according to Aristotle, matter is made up of 5 different things. And these 5 different things, when combined with each other in different ratio, they form a matter of a different shape and size. Dear student, Aristotle was very famous in that time. Due to this, many of people believe on the idea of Aristotle, though Democritus was somehow right about the concept of an atom. Keep in mind, both Democritus and Aristotle were philosophers, so they cannot prove scientifically that a matter has a smallest particle, and that is an atom. Philosopher can just imagine, they can give just an idea, and that was the reason mostly their concept was not believed at the same time. They need a scientific evidence. So after 2500 years ago, in 1808, a British chemist known as John Dalton gave his own concept about the smallest particle of matter. John Dalton did experiments, and on the basis of that he validated the idea, or he validated the concept of Democritus about the matter, about the smallest particle of the matter. John Dalton was a first person who basically validated the idea of Democritus about the smallest piece of a matter. According to John Dalton said that a matter is made up of an indivisible small particle, and these indivisible small particles are known as atoms. Atoms combine in a different ways, and due to a different combinations of an atom in a different ways, they make a different type of compounds like this. So this image basically represent a different kind of an atom, and when different kind or different types of atom combines in a different way, they form a different kind of compound or different types of matter. Initially, very few people believed about the idea of smallest particle, or about the John Dalton idea about the atom. But with the time, mostly people believed on the idea of John Dalton that matter is made up of smallest particle, and that smallest particle are undivisible and uncuttable, and these particles are known as an atom. But in 19th century, in 1900, the idea about the atom start to change. The people believed about an atom in a different ways in 1900. One of the key reason was that in late 1800, JJ Thomson discovered a new particle inside the atom, and that particle is known as an electron. So the concept which was given by a Dalton, that an atom is the smallest particle of a matter and it's combined in a different ways, they form different types of matter. That idea was slightly changed because in late 1800, JJ Thomson discovered another smallest particle inside the atom, and that smallest particle is known as an electron. So on the basis of the presence of electron inside the atom, JJ Thomson gave his own idea about the structure of an atom. JJ Thomson discovered electron, and which are much smaller than atom. So Dalton said that atom are the tiniest and indivisible particle of the matter. But JJ Thomson said no, atom are not the tiniest and indivisible particle of matter, because atoms are also made up of this even smaller particle which are much smaller than atom, and these particles are known as electrons. So JJ Thomson pictured an atom as a plum in a pudding, or a blueberry or berry in a muffin, like this. This is a kind of pudding which have a plum in term of electrons. So atom appear like a kind of pudding in which the plums, which are basically an electrons, present throughout the atom. JJ Thomson called his model plum pudding model. Thomson proposed that if we take an atom and split it open, so you will see that a little electron stuck throughout the atom, just like a plum in a pudding, or a chocolate, or a berry in a muffin. Thomson proposed that these positive charge are spread throughout the atom, whereas the electron are stuck inside the positive charges. So both positive charge and the negative charge will balance each other, and due to this, in general life you see a neutral atom. But just keep in mind, this was a big change from a Dalton atomic model to a Thomson atomic model, because Dalton said that matter is made up of a smaller particle and that particle is known as atom. But Thomson modified the Dalton model by saying that there are also another tiny particle which are much smaller than atom, and these particles are known as electrons. Now this time the concept about the atom changes in very short period of time. Since you know that according to JJ Thomson, an atom consists of a positive charge which is spread throughout the atom, and whereas electrons are distributed in different points in an atom. So they are just like a plum in a pudding, and that's the reason JJ Thomson gave name to his model as Plum pudding model. But this model was modified by Ernest Rutherford in 1911 by giving his own model. Ernest Rutherford discovered that atom has a center, and the center of an atom is known as a nucleus, whereas electrons are spread randomly near a nucleus. Rutherford with gold foil experiment proved that most of the area of an atom is an empty space, whereas positively charged nucleus is the center of an atom, or positive charge of an atom are concentrated to the center of the atom. Now question here is that if an atom consists of an electron and positive charge of an atom is concentrated at the center of an atom, then what will be going on with electron in an atom? So to explain the presence and distribution of an electron in an atom, in 1913 Bohr came up with his own model. Bohr said that atom consists of a nucleus just like a Thomson atomic model. This is a schematic representation of a nucleus. According to Bohr, atom consists of a nucleus just like a Thomson atomic model, but electron, instead of randomly distributed around the nucleus, electron act like a planets around the sun. So according to Bohr, electron revolve around a nucleus in a fixed path, and these fixed circular paths are known as orbits. So now people believe that this Bohr atomic model has somehow sense than the Rutherford atomic model and JJ Thomson atomic model. So if I conclude the Bohr atomic model, Bohr said that an atom consists of a nucleus. Positively charges are concentrated toward the center of nucleus, just like JJ Thomson and Rutherford atomic model. But according to Bohr atomic model, electrons are not randomly distributed around the nucleus, but electron revolve or electron spin around a nucleus in a fixed path, and these fixed paths are known as orbits. So electron spin and revolve around the orbit in near a nucleus according to Bohr atomic model. The Bohr atomic model make somehow a sense of the presence of electron around the nucleus. But just keep in mind, as you know that when a charge move in a fixed path around near a nucleus, it is a quality of the charge to release some amount of energy due to its motion. So this means that it will be a kind of difficult for a charge to remain in a fixed path for a longer time, and the atom may be destroyed in few nanoseconds. So still there are a lot of flaws in Bohr atomic model. So in 1920s, additional experiments were done to understand the structure of an atom. The main flaw with the Bohr atomic model is that according to Bohr atomic model, the electron in an atom move around a nucleus in a fixed paths, and these paths are known as orbitals. So the electron spin and revolve around a nucleus in a fixed path according to Bohr law or according to Bohr atomic model. But this is a serious drawback of Bohr atomic model. If electron move in a fixed path, then as you know that any charged particle, when it's moved, it's release some amount of energy, and this release of energy will cause or that may cause a collision of an electron with a nucleus or with a positive charge, and at the end of the day atom will be destroyed. So in order to understand the structure of an atom, Erwin Schrödinger gave his own atomic model. Erwin Schrödinger showed that electron won't spin in a fixed path which are known as orbital, but they will be more likely hyperactive flies. They will buzz around a nucleus of an atom, and they will be sketched out in a different shape. Since Bohr called the circular path in which electron moved, he called the circular fixed path an orbit. But Schrödinger called these hyperactive sketching orbitals, which mean that electron actually don't make a circle, but this is somehow spherical, or this is somehow random. So in quantum mechanical model, electron don't revolve in a fixed path or an orbit around the nucleus, but they buzz like flies in a different shape around a nucleus. So the major difference between Bohr atomic model, which is a classical model, and Erwin Schrödinger atomic model is the movement of an electron around a nucleus. Erwin Schrödinger model is known as a quantum mechanical model of an atom. According to Bohr, electrons are moving in a fixed path, and these fixed paths around a nucleus are known as orbits. Whereas according to Schrödinger, electron will fly, they will act like a flies, they will buzz around a nucleus, and their path will not be fixed, and the path which electron will follow around a nucleus is known as orbitals. So this is basically the current understanding of the structure of an atom. So now let us focus on the nucleus of an atom. Scientists in the same time discovered two more subatomic particles which make the nucleus. So we can define quantum mechanical model little bit more. Dear student, in 1919, Ernest Rutherford discovered protons, whereas in 1932, James Chadwick discovered neutrons. So now, according to Rutherford and James Chadwick, neutron and proton are the part of the nucleus. They are a subparticle of the nucleus. So now the correct way to express a quantum mechanical model will show the buzzing of an electron around a nucleus, and it will also have a nucleus with subatomic particle known as proton and neutron. So now this is a pretty much about the structure of an atom we think today. This model, which is known as a quantum mechanical model, is a real description of an atom. So in general life, rather to express an atom with a buzzing electron in a complex fashion, mostly the electron are represented with a Bohr atomic model like this. In case of representing an atom in a chemical bonding, for simplicity we represent atom like this with a proton and a neutron in a nucleus and electron in different fixed path or orbit outside the nucleus. So thinking about the atom in a simple fashion like this is very useful for a simple task like bonding steps, etc. But keep in mind, when we in actual case discussing an atomic structure of an atom in reality is not like this, but they are much more like quantum mechanical model. So this is just a simplest representation of an atom if you want to make a representation of an atom in an easy way. Like if you are representing an atomic structure in bonding, you can express an atom according to a Bohr atomic model. But still keep this in mind that this is not a correct way of representation of an atom. The actual correct existing way of representation of an atom is according to a quantum mechanical model.